Hey guys, so you're probably thinking, what the hell am I looking at? So, um, when I was considerably younger, actually, when I was in primary school, actually, or secondary school, I don't recall exactly, I was introduced to the precursor of this software right here. It used to be called Crocodile Clips, and it was split into three or four instances, so different pieces of software. And I remember it was just insane what this thing was capable of on a not very powerful computer, and it was absolutely fascinating. I think my physics teacher got me into this thing. Um, I don't recall whether the licenses that he used were legit or not, or whatever, but it's very, very long ago, and I'm pretty sure that despite me having pirated that software over a decade ago, or having given a pirated copy of that software, it allowed me to do something extraordinary. And like, not do something extraordinary, but to experience something extraordinary. And I remember it was a massive trigger for um, the path that I took in life. So I actually searched on YouTube about this software as it stands now, and I haven't seen anything. I just saw a very short video about something, and I thought about showing you guys this thing and what it can do, and maybe make it a bit more popular, because I think it's one of the most interesting learning tools that I've ever seen. It's absolutely fantastic, and you can get it for free for home licenses. So, as an introduction, what I remember Crocodile Clips was, it was a suite of three or four programs that you could install, and there was physics, chemistry, and technology. And the physics one had what basically you can see here, so motion, light and sound, and mechanics. I think it's gears named now. The chemistry one had inorganic chemistry and electrochemistry, and there was crocodile clips for electronics, which had these two things. The basic circuits were just part of electronics as a general. So I'm going to completely ignore this tab and this tab, and let me just show you a couple of examples first. So let's look at something in chemistry first. So you can open one of these things, and they're meant for educators, for teachers. So for, you know, teaching students and setting up virtual experiments. So let's see, manganese hydroxide and hydrogen peroxide. And if we unpause it, you can see there's a reaction going on. And what's very interesting is that you can get very detailed explanations of what's going on. So hydrogen peroxide is decaying into water and oxygen, blah blah blah. And I think the other one, we were supposed to just look at hydrogen peroxide decaying by itself into hydrogen and oxygen, which is much much slower than it's being catalyzed by manganese oxide. So you can see this one reacted so much that it blew the cork. I remember when this used to happen, when I was experimenting with this thing when I was a child. Blowing the cork or spilling would result in an immediate crash. Okay, let's look at something else. Products of burning. And if you burn carbon, you get carbon dioxide, etc. If you click this, you can empty it, and it's very nice because you can just you have everything that you need to set up a what do you call it, a complete experiment, and it gives you details, it gives you actual proper math, and it's fascinating. So this is just the chemistry, and these are just the examples. So what I used to like to do was create a new something. So you have a lot of the periodic table of elements. You don't have all of it, because I tried to set up a Weston cell and simulate it, because you can do electrochemistry, and you can simulate various electrolysis cells and stuff like that. So you have lumps of various things, and you can have like a Bunsen burner and light up a, what do you call it, a piece of magnesium, and it has that characteristic white flame. Or you have various chemicals that you can do because they provide you a what do you call it, a glass rod. So you have a glass rod somewhere, I can't seem to find it, and you can do the oh, here it is. You can do the copper sulfate, for example, and you need you can do the flame test. That was what I was going to do. So for me, a kid growing up in relatively, Romania wasn't very rich, so we didn't have that much. So if you see, copper sulfate burns with a greenish flame, and you can clean it and add something else. So for me, I have to take a break before I get overly excited about this thing. So let me explain why I found this so very interesting. Because in all my school years, I think we saw, so this is primary school, secondary school, and high school. So 12 years of school. I think I saw a lab 3 times. So we did a couple of chemistry labs and 1 physics lab, and that was it. So we didn't really have any money for stuff like that. So you can understand my frustration. So having this was basically a substitute for a complete lack of funding in the school system. So you can have any reaction within reason that you could think of. I don't think it knows very complex things, like, I don't know much chemistry, but I don't think anything more than redox reactions or stuff like that are very, very accurate. So I wouldn't put my wouldn't get a PhD thesis in chemistry based on this thing. So I'm pretty sure that if you heat up whatever it is, sodium sulfate in air over a Bunsen burner, something should happen. So I'm not saying that it's not interesting or it's not correct or it's not. It's actually fabulous. So you can do mercury distillation. So let me just try and show you that very quickly. So we need mercury. We need an Erlenmeyer flask, which is one of these, or even a round bottom flask works. And we need a stopper, which is here. And we need a condenser, and we need a small beaker, something like this. And you have hoses, and then you crank up the heat, and you look at what's going on, and you can see the temperature is rising. And you're gonna see that it gets to, so the current reaction is that mercury liquid is turning into mercury gas, And you can see that at 356.75 degrees C, mercury stops, like, the latent heat of vaporization takes over, and the mercury should start condensing in the condenser and dribble down in the beaker. It's actually very, very cool how, and you can see the volume is dropping. There's mercury vapor in here. So, and now the stopper popped because the pressure was too high inside, so I should have turned it down when and you can see here, for example, you have mercury, which is distilling over. And you can do all sorts of chemical reactions, and that's about it that I can explain about this thing. Now, let's go into, you have to hit change, and let's look at electrochemistry. And the basic apparatus changes. So you have, for example, I can have two beakers, and I can have a salt bridge between them. A salt bridge is one of the things in electrochemistry where you use it to exchange ions between two beakers, but not a solution. So we can have a voltmeter, and we can have a carbon electrode and a zinc electrode, and I think it was sodium hydroxide in both of them, and I think we can have a zinc carbon battery, or rather not. Let's see, sulfuric acid. Look, I made a battery, negative 1.12 volts, and it's very fun that you actually can add an ammeter in series with this, and you can see that it gives you around 5 milliamps or something like that. It's very, very cool. And you can do plating, so you can take a copper electrode, put it in copper sulfate and copper sulfate solution, and flate, for example, something else. So, and you have a I think you used to have a battery. They used to have a constant current power supply, but that was, I think, taken out because it was kind of confusing. Because when the, of course, in a simulation, a constant current power supply has infinite output capability, so infinite voltage capability. So I think it kind of led to some bugs and glitches and stuff like that. So we made a zinc carbon battery, which is very fun. And again, you can see detailed equations, and this is really crazy. Like, I can't believe why it's not more popular than it is, because at least in Romania, I don't think many people knew about this. I think it might be just a British thing, or used by exclusively by British people. It might be that everybody knew about it, and that nobody in my immediate circle knew about this thing. So, and you can see the reactions being exothermic or endothermic or whatever. It's actually crazy the amount of work that went into these programs, and just how interesting and how flexible, and how like, the possibilities are really, really, and they're not endless, but there's a lot of possibilities, a lot of things that you can do. And now let's look at something let's look at motion, because this was always, let's see, metal ground. You have grounds and you have slopes, and you can have, for example, a metal ball. And one of the things that I didn't show was that everything has properties, and now Newton's laws are demonstrated. So you can see that every force has an equal and opposite reaction. The black one right now is gravity, but for example, if we look at velocity and we give it a kick, you can see that we formed a basically an oscillator, a mechanical oscillator, And they have springs. Let's do a springy thing. And in order to catch this thing, I need to. That was a thing that I remember was being pretty difficult. So you need to pause the simulation to stop something. So. And now we made a chaotic oscillator, but you can see the sine wave nature of the thing. So let me just pause the thing again and move the spring somewhere and let it hit the ground, and that's why it was. So you can see just how detailed the things are. It's very, 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 very well done, and you can do lots of experiments like inclined planes and demonstrating how like, all the experiments that you can do conceivably in a physics lab in high school or sometimes even in university, you could do virtually in these things, and you can set them up very nicely, and you can do collisions and or so all sorts of stuff like this. And to me, this was again an exceptionally interesting um, program, and I spent a lot of time in this thing when I was a kid. And I see that they put in this thing, which is electricity and magnetism, which I didn't see yet. It's probably so you can have you can visualize the field lines in a magnet and electromagnetic coil field, uh, moving wire induction, and I don't know what to do with these things because this is a 3D space, and I think you can zoom. So this is a north pole, this is a south pole. Oh, and if I think that you can get a rotor, spin it 90 degrees and attach it somewhere. Let me properties and grids, snap grid, and it should be. You can. I think you should be able to stick this something. Stick it to something or rather. Or this is just moving. I have no idea what I'm doing. I have to admit, I didn't use these things in the past. Oh, this is a simple generator. So let's see, maybe I can get a. Oh, disconnects here. And now if we rotate this, we should get a thing. So we can tie two wires to the thing, rotate this 90 degrees so it's easier. And you can see that we have a electric current which lights up the lamp, and it's great because you can then put all sorts of graphs and show, for example, the current through the lamp in regard to, and let me auto scale it. So you can show the current through the lamp in regards to the way I'm moving the crank, and this is really, really, really cool. Like, where did you? I've never seen this in real life. Like, I've never seen anything like this ever. Like a magnet generator demo. So you can imagine my excitement when I saw this thing. Okay, light and sound. This is really cool. So let me just try and whoops. Let's put an optical space in here. I think I'm gonna have to do a new thing. Don't save. Okay. And you need an optical space in order to simulate the thing. So you can even do optics. So you have diverging beam, parallel beam, or array box, which is easier. It makes it easier to see how the rays behave. And you can have concave lenses, convex lenses, and you can change their refractive index. You can change their focal length. You can, do everything you would do in optics, and you just find it absolutely fascinating. So you have mirrors, and you have all sorts of plane mirrors, concave mirrors, convex mirrors, parabolic mirrors, and I don't remember exactly the definition of a parabolic mirror. I think it has two foci, or I'm not exactly sure. Anyway, you have, so if you have a, let me select this and delete this, and if you use a white light, you can see the prism diffracts and splits the things. And you can have a benzene prism, a water prism, a diamond prism, which you can see then it's so refractive that it bends it 2 times. And it's insane. Like, you can have all sorts of, you can screw around with this thing for months on end, I think, and not get bored. And you have slits, and you can simulate interference patterns. And I think, like, if this would be a coherent, let's go for red, like, you know, a red laser or something like that. Yellow, red. I think you can have a screen. You can put the screen in front of the, and I think you need to focus the thing on the screen. And let's see if it works or if I can do anything about this. Nope. Anyway, it also has propagation space things for, so 1D wave geometry, difference between, you know, explanation for how the refractive index works, a reflection, which is crazy to like see this. I'm sorry if I seem very excited, but I just, having seen these as a kid and going back to that place where this thing was making me very happy, and it's just, you can pluck a string, and I think you can then pluck it again. I don't know, because it would be far too complex, but you can pluck a string and you can see what it does and simulate it, and, you know, or you can hit it with a tuning fork and see what it does, because it gives you the, you know, oscillation behavior and stuff like that. And another really cool thing, which was the 2D. So if you go into electromagnetics, I hope this is clear enough, and it's simulating a point source of light of 9 micrometers, and you can have a cross section of the thing. So if you have a what do you call it? If you have a slit or a double slit, basically, you can do the double slit experiment. So you can see the interference pattern forming on that cross section here. It's just insane. So the amount of things that you can do in this program are just crazy. And one of the things that made me really like excited yesterday when I figured it out, like after a while, if you have a moving point source, you can do the Doppler effect. And I think this is now moving 125% the speed of light. So let's tone it down a bit, and you have the Doppler effect. So if we put a, whoops, pause, and reset it, and if we put a detector, actually let's put a detector here, and let's put another detector here, and a graph, actually 2 graphs, whoops, and you can see the Doppler effect. And let's set this as I'm sorry I didn't uh, set these before, but I'm trying to make it as um, I'm trying to share it with you the way I felt when I discovered these things. So you can see that if I auto scale this thing, you can see the further it goes away, the lower the frequency, and we shouldn't see anything around here for a while until we get a very fast frequency. So that's the Doppler effect, basically. And we still have that cross section again. It's completely insane for me, like being able to find this thing years ago and being able to explain myself why all those things are behaving the way they are. It's just crazy. Um, and there's more. Wait. So let's change this to technology and let's go to electronics. And there's a small glitch in this thing because you need to have a tray and so you have a schematic symbol like this. So let's do a 555 timer circuit, and there's got to be one. It's such a common thing that they actually have it predefined, you know. So we have everything you need for a 555 timer in here, and pin 1 like so, and we need a capacitor. 6 and 2 go together, and then you have 2 resistors, and pin 7 goes here, this goes here, and you can see how it's working, and just find it absolutely fascinating. And you can have a resistor going to an LED, and where is it? LEDs, basic components, symbolic LED, and you can have it to go like this, and the resistors 100 ohms, and it even tells you, dude, your circuit's gonna blow up. So you can of course bypass that by setting the components as indestructible. So there's a thing in here in simulation, make objects indestructible. So when you want to, I don't know, simulate a thing that maybe you have a different transistor or something like that that will handle it, you know that it will handle it, you can use the thing to bypass any common senseness. And you have N-channel MOSFETs, P-channel MOSFETs. I think you can do, I don't think they have JFETs, but that's not a big deal. So we can do quite a lot of things. And it also has, in the same thing, it has what was truly impressive at the time, because I think these were before Arduino ever caught up. So you had the picks and the pickaxes. So pickaxe were a company who developed a bootstrapping, like a bootloader for PIC microcontrollers, and then you could program them over a serial port, and they could run BASIC, and you could write BASIC code, and it would literally run just BASIC. And I think I remember being able to get one and programming it and doing simple things. And you can have, like, they had all of them, like the PIC 28 is a PIC 28F something, I don't remember exactly. So you can see that you can do mixed signal simulations, and the killer thing was that it can actually have programming. So you can program this microcontroller, and you can have various things like read digital pins into something. And so I decided to have a bit of fun, and and open, let's see this. So I built a multi-slope in this thing. Of course, it's terrible, but it works. So it's quite accurate considering the fact that like it's not accurate at all, but it's accurate in the fact that there's offset voltages on the comparator. I'm not using a comparator, I'm using an op-amp as a comparator. So you can see, look at the counter. The counter is basically the value of the digitized voltage here, and I'm going to explain what it's doing. So let's put it to -3, and once it resets itself, you'll see that it deintegrates on the opposing slope, and it should give us 241 minus 255 minus 15-ish gives you about the exact opposite of whatever 3 was. So just, it's not a multi-slope, it's a dual slope, but you get the point. So I have even have analog switches and all sorts of stuff like that. So it's crazy, and it's running very slowly. So I put a lot of capacitance in the integrator and very high value resistors to give it enough time. And so it's really cool. You can have a mixed signal logic programmable thing, which is very accessible for even for kids. I think this is very accessible even for children, and you know, it's just fascinating. So you can do anything you want in this, and I would really appreciate it if you go take a look at the thing, and maybe if you're a teacher, maybe integrate it, give those people some money. I'm not gonna monetize this video because I don't want to exploit them for free, because I got a home license, and I just wanted to show it off to other people just how cool the thing is and how many things you can actually do with it, and share a bit of my childish excitement regarding this thing, because it was just my childhood was basically, that's why I can't see properly now, like I have to wear glasses. My childhood was spent in front of a Pentium PC running this thing on a 15-inch CRT monitor or something like that. So for me, this thing was unbelievable at the time, and it still is remarkable to this day. And it goes so far as this goes as far as that it can actually program the thing. I forgot, where was it? I think the objects tab has disappeared. But you can take the program that you wrote here in the flowchart thing, and just a second. More. I can't see. So what I was going to say is that you can take the program that you have here, and you can have it upload to a microcontroller, the pickaxe thing, and it will run. So yeah, it's crazy. Anyway, I don't want to bore you anymore with this thing. I think we've gone through everything that was really worth mentioning. All of the software is very, very interesting. It looks old-fashioned. It looks great. Give it a go. Ask for I'm gonna try and find the link for the downloads page, and go give it a try and have some fun with it, and maybe you can share some of my excitement when I was a kid and I discovered this thing, because it was just the greatest thing ever. So instead of wasting money that I didn't have on parts that I would have ended up turning into smoke, or let alone having chemicals at my disposal like mercury and stuff like that, I used this thing and tried out every circuit in their examples and had fun with it, and it was just great. Yeah, so Thanks a lot. I'm gonna try and leave the link for the thing in the description, and I hope you enjoyed this. This was a crazy thing for me to see, um, and I'm amazed that it didn't catch up more. Just the thing with the, I think the reason it didn't catch up more um, with Arduino and the likes is that instead of C, you could program the microcontrollers in BASIC, which wasn't very. I don't think many people cared about BASIC, so you know. I think C and the way Arduino used the libraries and the fact that you could do a lot more on an Arduino than one of these pickaxes things. So, um, oh, here it is. Program real microcontroller. And you hit COM, whatever the COM was, and it would just program it. I'm not sure what the fault finding is. It's much more than we barely scratched the surface. So yeah, thanks a lot for watching, and that's about it. I hope you'll find this interesting. I would wave at you and say see you next time, bye, but you can't see my hand, so I'll see you next time.